So I want to talk to you today about the lab data generator. It's basically a system which allows us to go through multiple cycles of productive failure. Because anything we learn in life that's worth learning is done through going through planning, execution, looking at what you get, thinking about how to do it better, starting again, and going through that whole process, which trains you then to become a good troubleshooter, to really understand the relationship between all of the components and the sorts of results that you're likely to get. Now, this is something that we want to teach students when they're learning practical techniques. We want them to feel the pain from doing bad work and feel the joy from being meticulous and having good design. We want them to have lots of data to process and we want them to have troubleshooting skills, but that's all very difficult in a real lab environment. There just aren't the resources, the time, the staff, and so on to let that happen. In industry and in other professional practice, you'll often find that simulators are provided. The best example of this are the simulators that airline pilots train on. They reproduce every possible situation that a pilot might encounter, and that really equips the pilot to be able to deal with any situation that they deal with when they're actually flying a plane. Now, these simulators are based on the rules of physics and they deliver an experience to the pilot, both in terms of the numbers on the dials and also of things like motion and g-force. Now, what we've tried to create here is something that does a similar thing, something that allows somebody to plan and execute an experiment and get data and see whether or not the approach that they took and the decisions that they made and the choreography by which they organized things at the bench actually came out to give a positive outcome. And thereby go through these rapid cycles of reflection and redesign and productive failure. It's very important to realize that there are no predetermined outcomes in this. This is not like a choose your own adventure book where there are only a set number of outcomes. There's an infinite number of outcomes. The only things that we define in the software are the relationship between the chemicals and the processes like centrifuges or incubators that are going to cause an effect to the constituents in the tubes. Now, a good example of this is the spectrophotometric determination of metabolite concentration, in this case ethanol. So students are given 10 blood samples from people that have been accused of drink driving. They have to assess whether they're over the limit or not. If you want to see the full assessment, I'm very happy to send this to you. This is an assessment that's been done over a few years by over 800 students per year, and it leads not only to them obtaining all the troubleshooting skills that we've talked about, it allows a completely plagiarism-free assessment because everybody gets a different allocation of unknown samples. The other thing that's possible with this is that you can compute a market because the students can type in their estimates and that can be cross-referenced with what the computer generated. And so a large part of this can actually be automatically marked. The sorts of skills that you might expect students will get are incredibly varied. So they have to go through the design process, they have to be able to choreograph the execution, they have to show discipline in timing and note keeping, they get the data, they have to analyze it, and then the most important thing of all, they have to discern, do I believe this data? Do I trust it? Do I need to go and do this again until I get results that I'm sure of? And every step of the way, there's integrity because each student gets something different. And because so much is going on, there's a fantastic opportunity to train notebook keeping skills as well. Other implementations that you can see in the demonstrations are divided into three main classes really. There's number outputs, where the user gets spectrophotometric data or qPCR data, something like that. There are visual outputs where they're getting pictures of plates with colonies growing on them. And there's even what I call deep fakes, where I'm actually producing outputs that visually depict and are almost indistinguishable from the real thing. So I hope you have a good time looking at some of the context, and please get in touch if you're interested in making one for yourself.